Welcome to our vision series for SIGGRAPH 2021. Today, I'm talking with Mathias Røyrvik from Rodeo Effects. We're going to be talking about rigging today. I'm Will Telford. I'm a senior product owner at Autodesk, but the man of the hour here is actually Mathias.
Thank you for having me.
Well, one of the things I wanted to talk to you about, so we've been making a push into a more procedural, topologically independent way of working in Maya. We started that push with Maya 2020, where we introduced things like the original geometry plug and offset parent matrix and the proximity wrap. And we continue that in 2022 with improvements to GPU evaluation. We've introduced this component tag system, this Falloff system, morph deformer, solidify. Like, we're really pushing into a lot of these topologically independent procedural type workflows. And so I've seen you grab hold of some of these features and just really run with them. You have a great webpage with some good articles on there. There's one on there for my original shape, and then there's an overview of the fall-offs.
Having just the understanding of like something like the org shape in Maya, I think is something that just opens up a lot of possibilities, because it's one of those things that being able to kind of rig something once and then kind of easily update it is a really powerful way of working, right? And then like all of this kind of now culminating into like the kind of fall-off system that you've been implementing now is really just allows you to, it unlocks that kind of final piece of the puzzle where it's been like a lot of deformers are dependent on kind of painted weights. But now with the fall-off system, that's gone. I have a bunch of cubes. So if I just hide this plane, so you can see I have a bunch of cubes here, and basically the scale Y of these is being driven. And it's being driven as I move this around here. So you can see as I kind of move this kind of whole primitive around here, the primitive fall off, that's scaling up these kind of values for the cubes here. And how that's happening is that we're basically taking the fall off, the kind of weight function that we're calculating here, and we're passing that into a fall off eval. Now the fall off eval will basically give you per vertex weights for the geometry that you're passing in. And so I'm not going to show it now, but each of these per vertex weights feeds directly out into each of those kind of cube scale Y. And you could put this out to anything. You could have weights driven by this. You could feed this into whatever you want. And it just allows you to basically use any of these kind of things that you got going on here and just kind of drive some values. It is done by a friend of mine, Damien Gumino. I hope I say his name right. If not, he's going to hound me. But I just want to do like a quick little show of like, this was one of the things where it's, I think it's pretty interesting to have the proximity wrapping driven by these kind of joints here now. So what I'm going to do is I'm going to just select these kind of joints here. Actually, I'll probably just do these two just to kind of make it a bit easier here now. I'll go skin, bind. I'm going to do selected joints, and I'm going to do the proximity wrap. So what we get now is we kind of get this whole thing here now. So right now we don't really have, like, we can't right click and kind of paint it, but what we can do is we can go back in and kind of have our, and control this whole proximity wrap by using the components, sorry, the weight functions there. So we can see by default, we actually get a component fall off and transfer fall off that basically kind of mimics what you get with a typical skin cluster when you do like a normal bind. But we can go in and kind of take these and kind of drive these as we want. So what I'm going to do is I'll go and I'll just get rid of this, and I'll add in, first off, I'll just do a uniform fall off. And correct me if I'm wrong, but the uniform fall off is just like a flood value weight that gets set.
Correct.
So what I will have is I will have a primitive fall off that is basically like my elbow weight. So we'll take this up here, and I'm just going to make that a bit larger. And I'm just going to make sure that I kind of use the values here that we have to kind of shape that primitive a bit. So what I just want is I want this kind of primitive fall off to define the area that the elbow joint should be driving. So I'm just going to do something like that, and I'll make sure to change the start so that it's a bit larger here as well. And what I will do now is I will just add this in here. So we can now see that now that I have this, we can basically use this to kind of specify the area that we want to kind of add this. So as I'm moving this, we see that the weights are actually interactively changing. If we look at the actual kind of the original geometry here now, anything that we kind of do to this, if I go in, if I start to like extrude on this, we can see that this just works still. Like I can go in and I can just kind of increase my resolution, and we can just kind of change these deformations. Of course, we still need to be within the kind of fall off area, but I can, if I just go back here, and if I select my kind of org here, I can still go in and I can kind of modify these things here. Yeah, if I had that connected up nicely, but we can basically.
So I think one of the things worth pointing out though is this isn't just point pulling passing through. You actually just changed the topology. When you did that extrude, there are now new faces. You updated membership, you had updated deformation. If this, you just smooth there. So you can see the subdivision. You actually change the topology and your deformation continue to work.
Exactly. And like, as long as, this is one of the things that can often come up in production is that you might have like an approved shape, but you might go backwards and forwards and like, we need higher resolution to do like some nice kind of skin simulation wrinkle. This can pretty much almost bypass rigging now with the right pipeline. What I've done here is I've just kind of skinned this with a proximity wrap. But one of the cool things that this kind of allows now is because this already has the kind of component fall off, and the component fall off keeps the kind of original shape when you bind it, and it keeps that kind of original data. That means that with this component fall off and this transfer fall off already built in, we can do things like going in here and saying like, let's say this is the published model, but we can change it to like the working model. And this will now, the only thing that it's doing is it's just changing, if I can move this window, is that it's literally just changing the reference path. So this is still referencing in the rig, but in the rig model, we've got a reference to a model file, and it's just updating this. So that's just like the whole thing. So this didn't have to go through rigging. It didn't have to go through anybody. This could be, if a CG supervisor wants to test a new model before publishing it, test it on some shot animation or anything, this can just go straight into here as well. The only thing that it's doing is it's changing the reference for the Rhino model, and it's just changing from the published to the working. Or I can go in and I can say a custom model. I can go in and do like another one here, and it will just do that. So now you can see we've got like this guy here now, and now he's got like a bunch of kind of extra clothing that's going on here now. That's also, following the same deformation because it gets that kind of weighting already. It just works. Cool. So one of the things here as well with kind of going through and having the kind of proximity set up using like the fall-offs, I think some people might have, a bit of like hesitation getting into them. But I still think showing with the kind of workflow that I kind of demonstrated with being able to kind of switch between the kind of different topologies and everything, and just have that happen on the fly is still super powerful. And I think that's a big advantage over the skin cluster, even if you just want to go in and like actually paint your own wigs. And there's one way that you can go in and actually, for your kind of proximity wrap, go in and paint them as if it was a skin cluster. With the kind of the fall off eval, the component fall off, and all of these, you can suddenly have like a bit of a round trip into kind of skin weighting and back into fall offs and kind of go around with that. So what we can basically do here is I'm just going to take these, and what I'll do is I'll do bind skin, and I will just bind with one max influence and the proximity wrap. And what I'll do is I'll just go and skin with exactly the same kind of joints here now and skin it as a skin cluster instead. So what we actually get now is we get double transformation, right? Because we basically have two deformers doing exactly the same work. So what I can do now is I will reorder these so that I have the skin cluster before the proximity wrap, and I'm going to turn off the skin cluster so that now we only have the proximity wrap working. And if I jump into the good old node editor, what I'm going to do now is we have the component Falloff here, right? And because that's basically the one that gets created, that's where all of these kind of weights get set by default when you do your kind of bind. So what we can do is we can take the skin cluster, and if we open up this, we have the per influence weights that we can take from here, and we can connect into our weight layer here.
There's that array level connection that we made.
Exactly. It's boom, there it is. And what I can do now is I can go in, I can just do my normal right click, and because this will now go basically to the skin cluster. So I can now go in and on the shoulder and say, hey, I want to fix up these areas. And again, this is now painting directly onto the proximity wrap. So you can see as I'm driving that. And one thing that if you wanted to go a tiny bit faster, because this is a bit of a hack now, you can just go and paint your skin cluster instead. So you can just go in, do your kind of normal thing here. I'm just going to make sure that I do that. Go in here. I can flood that. And as soon as I now go turn off my skin cluster, turn back my proximity wrap. And what you just have to kind of watch out for now as well, if you're using the proximity wrap and you go in and you do your kind of weight painting, is that you just have to kind of up the number of drivers. So you can see here in the kind of in the back here, where I had like kind of smoothing going on between those different. So we just have to make sure that we just have like, if you got 4 max influences, you need 4 drivers. So that's basically how you can go in and paint your proximity wrap. And again, with the proximity wrap, even if you now were to just go in and delete the skin cluster or something and just have those weights in the component Falloff, it would just allow for you to go in and change that geometry on the fly, change that org shape, and just kind of mess about with that and have the weights automatically transfer for you.
Under the hood, when you were binding the skin and you were saying, give me a proximity wrap node, what it is doing, it is generating a skin cluster. It is taking the results of the skin cluster, pushing it into component Falloff, and blowing away the skin cluster. And
so that's why they're matching.
If you wanted to play around with it, the other thing that we've done that we started doing in 2020 is we started implementing these option boxes in the menu through Python. So the code to build the proximity wrap bind for the skin cluster is in Python, which it's in an area that's marked internal. And the reason it's marked internal is because we don't want you to build functions that depend on it as if it's a public API, because those things could change. But the logic we're using is all exposed through Python. So for anybody who really wants to have fun and really dig in there, and you like what Mathias is showing here, you can potentially go in, look at that function, call that function yourself, or modify it in a way that doesn't blow away that skin cluster, and see if you can build a faster weight painting workflow on top of this using that skin cluster. So do you have any thoughts on where you would like to see this go, or what's next for you? What are the pieces you would like to see us push forward on to kind of complete these workflows for you?
So for me, like in terms of this, I think there's a lot of really nice stuff here. I'd really like to see like a nice take a step back and kind of get some updates to the node editor as well, just to kind of introduce people a bit more into the node editor, because I think it's just like, it's a bit scary sometimes. And a lot of these things just allow you to, just have that, go in and kind of poke around with these nodes and kind of connect them together. And I think that would be a thing for me. And then kind of continuing on with expanding the number of deformers that you can easily kind of push these into. And for me, I'm really curious to see like how much of like USD can be pushed into rigging. And one thing that I'm really really excited about for the future, or like looking into, is more composable rigs, and not like I loathe large monolithic files.
Yeah.
Because it's like the larger the geometry, the slower the time to go in, the slower the fixes, all of these different things. So for me, it's a lot of these kind of base things, and then any other cool stuff you guys are cooking up, I'm all for it.
Cool, man. Well, thank you for showing all of this stuff. I would highly recommend that anybody watching this follow Mathias on Twitter. What's your Twitter handle?
It's at Saitaman. It's basically my name backwards and an EN. So
I didn't
making
pick
it
up
simple.
on that. I didn't pick up on that. All right, cool. So follow Mathias on Twitter. That's where I first saw all of these videos. And he was nice enough to put all those together in that post on his website. Be sure to go check out that website. There's some really nice things there. And he's really responsive on Twitter to people as well. So we've had some great conversations, and it's been fun to have those conversations in the public where everybody can chime in and learn from each other. So it's a really good place to have those conversations.
And a quick little note on the website as well. A lot of the things that we've kind of gone through here now, I've got example files that people can download to kind of test these things as well. So the kind of original one with the kind of scaling cube, I have that exact example. And for the kind of other things, I have not exactly this mesh, but like the standard Maya one.
Awesome. Well, thank you so much, everybody. Please go check out his website, download those files, play with these concepts. I think that Mathias has shown us some really creative uses of these. And I think, like I told Mathias earlier, our goal is to build up these modules and these components that can be used in different ways. And we've made them general purpose intentionally so that people can do the creative things you're doing. Whereas we never intended somebody to drive that cube example. It was built so that it could drive things like that. And so it's really neat to see what people are coming up with and ways they can leverage this when we make the outputs and inputs of these different building blocks more general purpose, so that they can be consumed and produced and used in ways that don't necessarily relate to rigging it all the time, right? But just relate to data-driven workflows throughout Maya. So thank you for showing people how that can be done, and please continue to work with us so that we can keep pushing things forward. And good luck at Rodeo. Can't wait to see what your next project, or at least your first project coming out of Rodeo, looks like.
Same. Thank you for having me. It's been fun playing with this, like I said. And yeah, I really hope people dive into it, because I literally just did this in a couple of days, poking at these things, and it's really easy to get into as soon as you just kind of click these little things. And I'm super excited to see what people can do with it.
Awesome, man. Well, thank you for joining us, and thank you for everybody for logging in.